review our product rule. What does product mean that we're doing? Multiplying. So if you have two different functions that you're multiplying together, and we're going to do the derivative. So d dx is our instructions that mean take a derivative with respect to x. You know how you usually have y equals and then all x's? X is your independent variable. So you have two functions multiplied together, and we're going to use u's and v's. So make your v's really pointy so that you can tell the difference. Again, and we were having this conversation before you guys all came in about like the letters of the alphabet that get used. I try to go with what like most calculus textbooks would use in case they go to look something up somewhere else. So I don't love U and V, but that is what we're going to go with. All right, so what does your product rule start with? What are we going to put? Yeah, the first function, which would be U, and then what? Yeah, V prime, right? Derivative of the second. So you have the first function, derivative of the second, plus V, so the second function, and then U prime, derivative of the first. Cool. What I'm going to teach you, and this is called integration by parts, is how to do an antiderivative with your product rule. So we're doing that backwards. Your U substitution was for a chain rule in reverse. We're going to do a product rule in reverse. So if your functions are continuous, then what we're going to do is integrate or do an antiderivative of both sides. So if this means derivative and we do an antiderivative, what happens to those? If they cancel out, you'll just have U times V equals. So we're doing an antiderivative. A derivative and an antiderivative are inverses. They cancel out, all right? This term right here, when we do our antiderivative, it's going to be U dV. The V prime symbol, when you're doing your antiderivative, becomes that dV. Now, I understand those don't match, but that's okay. That's kind of how this formula is. Plus, and can you take what I just explained to you about that one and apply it to this one? What is it going to look like? Yeah, V du. Perfect. Okay. Now, what we want to do is get this term by itself. We want that to be alone. So this is like your formula. If you want to put like hearts and stars next to that one, we want our integral u dv to be by itself. That's like the goal of what we're finding. And so if you want that alone, you would take this term and do what? Subtract it. So it's going to be u times v minus integral v du, which I understand is kind of like the alphabet threw up on your paper. You're going to have to just trust the process. Once we do a few of these, you'll start to get the hang of it. But like, bless you, most things in math doesn't make sense until you take it and do an actual example. But you guys all hung in there with me. All right, and last thing before we jump into a problem, dv must include the dx from the original problem. So that dx has to get substituted in somewhere. And this is going to be similar to the u substitution that we did, but just like a little bit more complicated. Okay. So looking at the first one, do you see how there are two separate functions? First of all, what are our functions? What have we got? You have x, and then we have e to the x. So we need to let u equal something. Oh, it actually is going to be x. Hold on a second. And then we need to let dv equal something. Just remember to hit end on your password. So u is going to be the x. That is correct. All right. dv is going to be the e to the x dx. You have to include that dx with the dv part of it. If you're like, hey, Ms. Cole, what if I do it backwards? I'm going to tell you the exact same thing that I told you when we did u substitution in the last unit. If you do it wrong, the problem will simply what? It will not work. It will just like your pieces of the puzzle will not fit together, and you will go, oh, whoops, I should swap those around. Do you know what I'm saying? Basically, if you're not a giver upper, you will eventually get the right answer, because if it doesn't work, you're going to just swap it around. Okay. So this is u. We're going to find the derivative. What is our derivative of just plain x? Yeah, 1 dx. Good job. Perfect. 1 dx. Now here we're going to do an antiderivative, and that's why this is so tough. You have to completely switch gears. You're like doing derivatives, you're doing antiderivatives. But I started with a softball one because e to the x is going to be e to the x. It's itself. Okay? Now, if you set it up like I'm showing you here every time, look at the first part of your formula. Do you see how it's u times v? If you set it up like this every time, you can remember that the first thing you're going to put is kind of like this diagonal here. Do you get what I'm saying? Like if you're just staying organized and if you just write things everywhere, that's not going to work. But it's going to be x times e to the x. All right, cool. We got x e to the x. It's going to be like that diagonal minus integral. And again, if you set it up the same way every time, it's going to be v du, which is going to be like, yeah, this. Oh, so you guys are saying it before I can even, I'm pointing it out though. It's going to be like this lower line, but it'll be e to the x dx. And so that first part just is what it is. Again, I started with like a slightly, I start with an easier problem. You're just going to copy that part, whatever it is. Sometimes that part gets kind of complicated. Just recopy it. Don't do a copy error. Copy errors are the worst. And then you're going to do the antiderivative of this part, which again, e to the x is just e to, and what do we have to not forget to put at the end? Let's see. Perfect. I know, right? It's all X's and E's and things. All right. But you know what? You handled that well. Question. Yes.
Wait, did we not have to put, like, when we were labeling what each of our things were, when we labeled what B was, did we not have to put plus C there?
No, it only goes in your final answer. Think of this as like the U substitution we did. That's almost just like a margin problem. That's our notes to ourselves of what we're substituting in. This is our like actual work for the I guess if you were a real genius and had like nobody tried to do this and you had like a photographic memory and you could do this in your head, that's not actually part of the problem. This is the problem. You guys are going to write this, yes? Okay, cool. All right, so let's try another one. We have U and we have dV. What do you think we want to let each of them equal? U equals it. And you want the U to be something that's going to cycle down to nothing, sort of, okay? And dV is going to be like everything else, yeah, like the rest of that stuff. Oh, I did it. I wrote something wrong. Can anyone catch it? Yeah, that should be dx. Thank you. I realized as soon as I wrote it, I was like, hey. I mean, I did that on purpose so that you could all. Okay, so du is going to be just dx. The derivative of x is just 1. So you could put a 1 in there, I suppose, if you wanted to. Now, let me talk you through this. First, let's do the cosine part. Antiderivative of cosine. You need a function that if you did the derivative, you would get cosine. Cosine, perfect, sine. Actually, I'm going to write what the answer is and have you guys tell me why it's like that. It's going to be 1/2 sine of 2x. Yes. Because if there's a chain rule where you chain on a 2, you need to cancel out or divide out the 2 with a 1/2. Okay. But if it's something really simple like that, I would just put the fraction out front. For example, because I see some of you looking at it. If it was cosine 7x, what would we have put? 1/7 sine 7x. Like you're just putting the adjustment number. And somebody even said it's a U substitution. We just didn't write it all out. Okay.
So if this, for future problems, we just like, let's say it's like a 3x.
Yeah. 1/3. Just slap a 1/3 in the front and you're good to go. Yeah, and I have another one on the back that's like that. So correct. Yeah, no, you're right. It is. It's the integral, or the antiderivative. Good, perfect. All right, now if you write it this way every time, the first thing you're going to do is this diagonal, okay? I would probably put the 1/2 in front and then the x. You could write it in whatever order you want though, but I'm going to write 1/2 x sine 2x. And just as a heads up and a pep talk, you're going to have to write that again. It's a little bit of writing. You're going to be okay. What comes next? Look back at your formula. Minus integral. And then again, if you set it up the same way every time, it's going to just be these two. So 1/2 sine 2x dx. Perfect. You guys put it all together. That was good, like teamwork. Everybody like said part of the problem. All right, so copy this. Just don't do a copy error. Copy errors are the worst. It means you know exactly what you're doing, but you just wrote something wrong. And we're going to do what we just did again. So if you were like, hey, I didn't quite get it, we're about to do it again. Antiderivative of sine, negative cosine. Perfect. So what's going to happen to these negatives? Okay, leave a little gap. It's going to be cosine 2x. You would need to multiply on another 1/2. Good. You're doing it again.
So it'll be what? Yeah.
It'll be Good, perfect. And then what do we have to put at the end? Plus c. Once you do the antiderivative, you don't put the dx anymore, you put your plus a constant. I think I'm going to start you on the next one and then let you try it, okay? We'll see how it goes. We'll just do the labeling together and then I'll let you guys try and finish it. You can work with your partner. What do you think we want to let u equal? Perfect, okay? dv e to the 5x dx. So I'm going to pause the recording there, but as a heads up, do you see how there's a 5x? What are you going to put in front of your antiderivative? A 1/5. Perfect. I'm going to pause and want you guys to give it a try. So what did you all get for du? All right, 3dx. There's just a 3. The 3 is kind of just there. Just leave it be, okay? And v would be 1/5 e to the 5x, okay? So again, if you set it up this way every time, the first thing you're going to do is multiply on this diagonal. Now, if you have a 3 times a 1/5, that's just going to be 3/5. But you can certainly write 3 times 1/5. That boils down to personal preference, how you want to write that. I'm going to go ahead and put a 3/5. So 3/5 x e to the 5x. So we just multiplied these. U times v.
Oh, I just didn't like simplify it, by the way.
Yeah, that's personal preference. You just didn't simplify as far as I did. Are you with me? Okay. Okay. What's going to come next? Minus, good, integral. And again, if you set it up the same way, you're going to use these bottom two. So it would, again, be 3/5 e to the power 5x dx. Okay, we got there. Let me get us all back together. This first part, you're just going to recopy. Again, just don't do a copy error. That's always a bummer when that happens. And you're going to do another antiderivative. Let me cover this up real quick. Because you have that 5x in there, you're going to need to put in front what? 1/5. Okay, I'm going to talk you through it. There's already a 3/5 there. If you multiply by another 1/5, it's good. It's going to be 3/25. 5 times 5 is 25 is what happened there. And then what do you put at the end? Plus c. You might have written yours different, but it means the same thing, and that's totally okay. Or do you want to tell me what you had? And
You had the 3 on the outside and then added the x. So
that's okay. That's not a problem. Are you saying like, and then like this was what you had for that first term?
No, for the second.
Oh, okay.
I didn't integrate first.
Oh, okay. Do you understand what happened?
Yeah.
Okay.
But do you have to, like, on the multiple choice?
As long as you can look at the choices A, B, C, and D and pick the right one, then you're good. So if you can get close enough to the right answer that you can select A, B, C, or D, then you're okay. Okay. Maybe write a little smaller for this one. All right, off to the side. And we're going to do this one together. If you want to work ahead of me, that's fine, but let's try to stay as a group. What do you want to try and let u equal? X squared, perfect. dv would be like, yeah, the rest of it. Okay. So what's your derivative of x squared? 2x dx. As a heads up, what do you notice is different about this one than all the other examples we've done so far? What does it have in it? It has a variable. Okay, so just heads up, this one's going to have a little bit more to it. All right, antiderivative for sine, negative cosine. Nice job, guys. All right. So next step, we're going to multiply u times v. That would be what? Yeah, I would put the negative out front. Negative x squared cosine x. So multiply these two. And then minus integral, and you'll multiply these two together, which would be, oh, actually, since we have a negative and then another negative, can we just go ahead and make those positive? And it'll be 2x cosine x dx. I'm about to not be your favorite person, but that's okay. This can show up on the AP exam. What do you notice about this? You have to do it again. There's a second layer to it. Okay. What's that movie where you have like a dream inside of a dream inside of a dream? Yeah, it's like that. Okay. It's like the second layer. What do you want to let u equal? 2x. You're going to be okay. I even have a sign that says it. All right. dv is going to be, yeah, cosine x dx. Now watch what happens. What's the derivative of 2x? And what do you notice about that? There's no variable, so we know we're going to be done after this one. See how we cycled it down to where we don't have a variable anymore? All right, what is v? Antiderivative of cosine would be sine. Heads up, because it's going to be about this long. I told you I wasn't going to be your favorite person on this one. All right, but I'm the messenger. This is, you can write an angry letter to College Board, okay? So you're going to copy this first part. It's sort of just there. Just don't do a copy error. And then for this one, you're going to do u times v. So 2x sine x minus integral.
Wait, why are we doing minus x?
Because that's what our formula is. It's u times v minus v du. Two side. We had to do it again. It's like a dream inside of a dream. I told you. And then you call, yes, good job. Don't have a bad attitude about it. Anyone can rewrite. I could pull in anyone that never took calculus in their life and tell them to rewrite this on the next line and they can do it. So you can do it too, all right? And then what's your antiderivative of 2 sine? Negative 2 cosine. So it's actually going to be plus 2 cosine, and then like the cherry on top, plus c. I will hold on. It's a lot to look at. We had to do it twice. We had to do the integration by parts 2 times. I mean, this started with an x squared, because that was a good question. That was a what if this happens question. What if this was x to the 5th? It'd take you 5 times to cycle down to, do you get what I'm saying? You could do it. The most I've seen is 2. Okay. But that is fair game. But that's the most I've seen is 2. Yeah. Like a higher power. Because you have to get it. So you'll know ahead of time what you're in for, like before you get there. All right, we're going to try 2 more. This one's a little bit of a curveball. Because what does it feel like you should let u equal? Okay. When there's an ln, you need to let u equal the ln part, and this is why. What's your derivative of ln? And that is going to cause x's to divide out, and that's what you want. You want them to go away. So sort of the exception to the rule is when there's an ln, you need to let that part be u, because you're going to get some stuff to cancel out. Correct. If you do it wrong, it will not work, and you will go whoops, and then you'll swap them around. As long as you're not a giver-upper, you will eventually get the right answer, because these problems are set up like little puzzles where all the puzzle pieces fit together. If you pick the wrong thing, just go whoops and then try something else and it'll fit together. Yes, thank you. Sorry, I got so excited to explain that it was 1 over x that I forgot to put. Are you going to say the same thing? And that's, you want to keep on me about that, and each other and yourselves. The notation has to be perfect in a situation like this because it all fits together. All right, so dv would be the x squared dx. Oh, you're ahead of me. V would be 1/3 x cubed. Perfect. Okay, so your first step, you're going to multiply this diagonal. You're going to do u times v. I would just put the 1/3 out. Actually, I would probably put the 1/3 x cubed out front. But again, that boils down to personal preference, what order you want to put that all in. If it's multiple choice, you'll be able to pick the right answer. All right, minus, and then what? Integral. And now watch what happens here. We're going to multiply these together. But this is why we did it this way. Do you see how this is x cubed and we're multiplying by 1 over x? And I heard somebody whisper it back there. It's actually going to be x squared. So we've got a 1/3 x squared dx. And then one more step. So do you see how this is 1 over, well, I'm kind of caught in here. Do you see how that's 1 over x, and we're multiplying it by the x to the third? So one of the x's cancels, and it becomes squared, which is what we want. That's why we chose it to be that way, so that that happens. All right, so you're going to just copy this first part. Just don't do a copy error. And then what is your antiderivative for this piece? Anyone want to give it a shot? 1/9, good, because a third times a third. X cubed, and then, beautiful. All right, we got one more. Give a good handshake. Nice. Yeah, thanks. See ya. All right, last one. When there is an ln, you want to let u equal ln. That's kind of the exception to that rule. So what's left for dv to equal? Dx. Now, can I make a suggestion? I would put a 1 in front of it in that case. It helps me figure out what on earth I'm doing, so it might help some of you as well. It's not necessary. You can just put dx if you want to. All right, what is our derivative of ln? Yeah, 1 over x, and I will remember to put the dx this time. For v, this is why I like putting the 1 there. Antiderivative of just 1 is x. And sometimes if you don't put a 1 there, then you might forget or, whatever. Anyway, that's my suggestion. So you're going to multiply across. It's going to be x ln x minus integral, and this is kind of nice. What's going to happen here when you multiply these? Yeah, and it will just be 1 dx, or you can just put dx. I like to put a 1. That's me personally. So that first part you just copy, just don't do a copy error, and it'll be minus x plus 2.
Oh, wait.